In this video, we'll be talking about removable versus non-removable discontinuities. So, discontinuities. Hopefully you can decrypt my shortened English. So, what is the difference between removables and non-removable discontinuity? It's in fact very easy, and I'll explain it right now. So, removable discontinuity is just a hole. So, you have a hole, some point where at only one point the function is undefined. So at x equals, let's say this looks like x equals 3, right? This is a removable discontinuity. It's simply a hole. So a removable discontinuity is just a hole, nothing else. The only removable discontinuity. And it can be easily plugged in. So you just need to plug in one singular point into this, and you can get rid of the discontinuity at x equals 3. So plug in a single point at x equals 3, discontinuity gone. But what is a removable, non-removable discontinuity? Anything other than a hole, any discontinuity you can think of, anything other than a hole is a non-removable discontinuity. Like an asymptote, right? A vertical asymptote. So as this function approaches 0, it never approaches 0, but as it approaches 0, it goes on to negative infinity and positive infinity. Well, you can't just put a point here and then it's continuous. You cannot. So vertical asymptote, discontinuous. Okay, how about for a function that looks like this? Well, you can't plug in a point. It's not a hole, so you can't just plug in a point, and it's not removable. This is you can't just plug in a point and then it's continuous. Sorry. This is non-removable as well. All right, what's another non-removable one? This is also non-removable. And the reason why is because you can't just plug in a point. This actually requires you to infinitely plug in many points. So an infinite number of points you have to plug in before this function becomes continuous. Now, why is it an infinite number of points? Because in this specific case of the hole, even at x equals 3.000001, well, there's a value at that point. Just anywhere other than x equals 3, there's a value at the point. And even at x equals 3.00000 blah blah blah, infinite number of zeros 1, well, there's still a value at that point. Okay, maybe not infinite number, but like let's say quintillion, all right, a quintillion zeros. There is still a value at that point. But if you get to x equals 3, there's no value at that point, and that's what defines a hole. Now, for this case, well, since there's an infinite amount of numbers between this point and this point, so let's say this point was x equals -2, and this was x equals -1, there's an infinite amount of numbers between -1 and -2, because you can just keep adding zeros. You can say 1.0001. Okay, is there a number between 1.001 and -2? Yeah, there is. There's -1.000000001. Okay, you can just keep adding zeros, and there's an infinite number of holes between these two discontinuities here, between these 2 points here. So that's really all a discontinuity is, or a removable discontinuity is. It's just a hole. Only at that point you don't have a value. You can just plug in something and boom, you're good. This requires an infinite amount of things to plug in, so this is a non-removable discontinuity. And that's just it. Super easy, just like that. Thanks for watching.